about gases. Gases are a state of matter that has no definite shape or volume. There are many laws that define the way gases act in ideal conditions. These laws are named after the scientists that discovered them, such as Boyle's law, Charles' law, Gay-Lussac's law. There is also a combination of laws that's called the combined gas law, and a final law that explains the conditions gases should be for these laws to apply, which is the ideal gas law.
Boyle's law states that the pressure and volume of a given gas are inversely proportional if temperature remains unchanged. As pressure increases, volume decreases because molecules are forced together. As you can see in the following graph, the relationship between volume and pressure is inversely related. But in the other graph, if you take the inverse of either volume or pressure, the relationship is directly related.
At constant pressure, the volume of a given gas increases or decreases by the same factor as its temperature. As temperature increases, volume increases because faster moving particles collide harder and push each other farther apart. As you can see in this graph, we can observe that volume and temperature are directly related, forming a straight diagonal line.
The ideal gas law is the equation of a state of a hypothetical gas. Although this has several limitations, it can describe the behavior of gases in several cases. The formula for this law is pressure times volume equals mass in moles times the ideal gas constant times temperature.
The Gay-Lussac's law explains how increasing temperature of the gas under constant volume and number of particles increase the pressure of gas. The formula is pressure 1 over temperature 1 equals pressure 2 over temperature 2. As you can see in this graph, pressure and temperature are directly related.
The combined gas law is a combination of Charles' law, Gay-Lussac's law, and Boyle's law. This one states that the formula of pressure times volume divided by temperature is proportional for any ideal gas.
After reviewing all the laws, we found Charles' law to be the most interesting. We found it amazing that a change in temperature can change the volume of a gas. That's why we decided to test it.
So let's check it out. Okay, so now we're going to start our experiment.
The materials we need are a piece of ivory soap, a piece of paper, and the microwave.
Okay, so our first step is to open the ivory soap. We will place it in the paper. So the second step would be to place the paper and the soap inside the microwave and set it to 2 minutes. Now we're gonna wait and see how the reaction happens. Now, here we can see the results. Because of the changing temperature, the gas inside the soap made it expand and create this foamy solid. Look, we can take a piece of it. It's like a really foamy feeling.
We used ivory soap because this kind of soap is peculiar because in the manufacturing they put air pressure in it, making it less dense than water. Therefore, when it is put into water, it floats rather than other brands which sink. So, how does this reaction occur? It's because, as Charles Law says, volume and temperature are directly proportional. So an increase in volume in temperature will cause an increase in volume. So as we can see in this example, when we increase the temperature with the soap in it, and the volume increased to this foamy solid. In conclusion, based on our experiment, we could find out that Charles' law was really accurate. We saw that the change in temperature would actually increase the volume of the soap. So thanks for watching, and I hope you've enjoyed it.